So the question says, you've designed a Ferris wheel of diameter 20 meters that rotates at a rate of 1 revolution per minute. How fast is a rider rising or falling when he or she is 6 meters vertically away from the horizontal line passing through the center of the wheel? All right, so the first thing I recognized from this statement is how fast is the rider rising or falling? So maybe along with this, I graphed first. So I said basically the bottom is like the ground, and so the top would be 20 because it's a diameter of 20. Thus, the horizontal line passing through the center of the wheel is going to be at 10. So what I said was I drew this triangle. I said, okay, so if that's 10 meters for the radius, this could be like our y, or 6 meters when it's 6 meters vertically away. And then later you'll see how we solve for 8. So how fast is it rising or falling? We need basically the slope or the rate of change for y, because that would be the height of how fast it's going down. So to solve for dy over dt, we have to come up with these few equations. So using SOHCAHTOA, we can solve for y. So I said sine of this theta, which is opposite over hypotenuse, would be y, which is that height, over 10, which is the radius. Rearranging it, put y equals 10 sine theta, just by multiplying the 10 over. And then if you take the derivative of that and using chain rule, you'd get 10 cosine theta times the derivative of theta over t, because we have it respect to t, not in respect to theta. So we have to do that chain rule. All right. Okay, so the next step would be to solve for d theta over dt. So this was kind of given to us. You just had to realize it in a way. If you think about it, d theta over dt is just that, is the change in how the rider is going around the wheel. So they give us that it rotates at 1 revolution per minute. So using basic cross multiplication, we can kind of get rid of revolutions and change it to radians per minute just by multiplying by 2 pi. And so this is actually our d theta over dt, which is 2 pi radians per minute. Okay, so the next step is solving for what I was kind of talking about earlier, that last part of this line or triangle. So if we know the other sides are 6, 8, and 10, 6 and 10, we can solve for 8 just by using Pythagoras' theorem, which is a squared plus b squared equals c squared. And I solved for 8. Okay, so then again, using SOHCAHTOA, you can find cosine theta using just basic trigonometry, which is 8 over 10 adjacent over hypotenuse. And then using basically these two squared values, we can plug in into this, into the dy over dt equation, plugging in 8 over 10 and 2 pi, and you get 16 meters per minute, which is pretty handy. And that would be how fast the rider is rising or falling at that given